Okay, hi. My name is Dr. Ben Newman, and I study coronaviruses, and I'm going to try to answer your questions. Next question, and probably the last one for today because I'm getting tired, is from Uncle Ted. How you doing? Yeah. Let's see. And, whoa, all right, we're going for the big questions today. What is the lifespan of a COVID antibody? Oh, man, all right. Glad you asked. Yeah. The answer is we don't know, but here is how we can estimate it, and I think the estimate will be pretty good. So, the cells that can make antibodies, those we know can hang around for a minimum of 6 months, and we think that they can actually hang around in some cases for up to several years. So, that's the first thing. You have the ability to make more until that cell goes away and dies. And then once that's happened, you have to kind of reinvent that cell in order to make another antibody. So that's one part of it. Second part of it is once the cell has actually made an antibody, how long does the antibody last? We can estimate this from when they put antibodies into people as therapy for different things. Like the data that I'm taking is from one of Regeneron's like internal presentations. I don't know. They haven't published it properly that I can find, but it looked like okay data. And so they looked at the amount that they put in, so they know exactly where they start, and then it goes down, 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 and they followed it for several months. It looks as though at least some trace of the antibody is going to hang around for about 2 months, but the half-life of the antibody is going to be more like a day and a half, maybe a day, yeah. So every day, imagine you have half the antibody you had the day before. Thankfully, they don't just put in like 75 antibodies. They're going to put in so many antibodies that, yeah, it's a really massive number. And so you can lose them steadily and still have them do at least a little bit of good, we think. Third question, though, that's related to this would be, well, how many antibodies does it take, to get to the Tootsie Roll center of a Tootsie Pop, to actually neutralize a SARS-CoV-2 particle? The answer there is, we don't know, again, but we can estimate it. There is a really neat relationship. And this is from an older paper by, I believe it is Erica Ullman-Sapphire, and I think Dennis Burton might be the other person on that paper. And what they did is looked at all the old literature. So what people used to do is they would get antibodies, and they would have a virus, and they would put enough antibodies on the virus. They'd try different concentrations till they figured out this is the amount of antibody that knocks out half of the viruses, something like that. And then they could take virus and antibody at that exact concentration, put them on an electron microscope, just look at them and count. How many antibodies did I bind? Yeah. And if you want to make it a little easier, you can put a little drop of gold, a little gold molecule on the antibodies. That makes it much easier to see in the electron microscope. And then, yeah, you just count the dots surrounding each little virus, and you come up with a number, and you report that number. And there you go. And so, for teeny-weeny viruses, the number is about 4. For giant things like bacteria, the number is in the thousands. And it seems to be related to the size of the virus or bacterium that you're trying to neutralize and basically stop from starting an infection. So larger things take more antibodies. Think of the antibodies as occupying a certain amount of space, like just filling in one little puzzle piece on the surface. And so if you get one antibody, you're good for this area, but you've still got to protect against all the rest of the virus. Because if it can grab onto you with any one of those spikes, then theoretically it can start an infection. And so we think the number of antibodies that you would need to stop a coronavirus, based on its size and the way all these other viruses work, would be neighborhood of 40 to 50. That seems like the right ballpark. Individual antibodies bound to one virus particle. And so you're talking about covering up something like half to 2/3 of the spike proteins on the surface in order to achieve neutralization. Now, there may be a few antibodies that can do a neat trick. If they can reach around and one antibody, they're sort of shaped like a Y on top, if it can grab onto 2 different spikes, then potentially you may only need half of that antibody, but then you're still talking about 20 actual antibody molecules that hit exactly the right bullseye, perfect spot in order to neutralize one virus particle. The other thing in this calculation, though, is that there are at least 10 and maybe as many as 300 viruses that look like a coronavirus but aren't able to work for every one that actually looks like a coronavirus and is able to start an infection. Depends on how you do the test. It depends on, a lot of different things, but that's why there's a range on that. So it's not just 40 or 50 antibodies that you need. It's, let's say, 50 times 100 antibodies that you need in order to knock out one infectious unit, prevent one cell from becoming infected by this virus and its horde of mutant, siblings. So the antibody is a powerful tool, but you need a whole lot of antibody to do anything useful, which is why in the past I have been pretty darn, I gotta say it, skeptical about antibodies as a therapeutic of any sort. And it looks as though they do have some at least limited value against COVID-19. The Regeneron antibody does seem to knock down the amount of virus that's present. It just doesn't do what I would like to see it do to actually stop people from dying. And I think that's what people want in a therapy for the most part. I think that's just beyond what you can really expect from antibodies. They were also looking at antibodies against some markers of the cytokine storm, the sort of raging immune response that is what damages people. And the study on the interleukin-6 antibodies, they got another big study in, and once again, this shows that interleukin-6 antibodies that knock it out do not seem to help. That was one of the great hopes right at the beginning of COVID. We learned there's a ton of this stuff where there's a ton of damage, and so it makes sense. You knock down this marker and you're knocking down the damage. Turns out it's probably not the marker that's causing the damage. It's probably something secondary associated with the markers that actually end up leading to the damage. And so we're tracking down a side effect rather than a direct, cause effect kind of thing. So that's fine. That's how you learn. That's how science works, one little step at a time. So those are all the ways that the COVID antibody lifespan could be interpreted. And I think generally, it means that antibodies are probably going to be the easiest to measure and potentially the longest lasting component of immunity after either infection or vaccination. So I guess we should get used to them. Thanks very much. Very good question. Very big question. Hope everything's well. This has been Ask Dr. Ben.